Awesome. Okay. So memory, yay. Have y'all hit memory in PC hardware just yet? Okay, cool. So this is coming right off the heels of stuff that you've already dealt with. Really, yes, perfect timing. You couldn't have done that 2 minutes ago. Sweet. So last week, I imagine you guys dealt a lot with the hardware side of memory. Was there a lab where y'all installed it? Popped it out, popped it back in? Any of that? A little bit? Okay, cool. So you were supposed to do yourself a lab on that. Okay. So on the software side of this, I think that's really where we're going to focus our attention. With the PC hardware exam, or with the A+ exam, they really want you to know about old stuff, like really old stuff, like 20 years ago stuff. So we gotta reach back. We gotta reach way back. So the first thing we'll talk about is DDR. But we'll kind of get a bit of a history lesson as well, because we've got SD-RAM before it that was popular in the 90s. But that's really kind of as far as we're going to go. So SD-RAM, synchronous dynamic RAM. So what this is about, RAM in general is, I think I've mentioned it before, but it's really just about actually remembering what it is that you're doing. So for instance, I've got Chrome running here with 3 separate tabs. I've got, no VMs, but VirtualBox running in the background, OBS running in that, Task Manager, and some File Explorer as well. You can see that over here. Oh, come on. What's going on? Wait. We're not doing it. We're just not doing it today. There. Cool. Okay. I don't know why that's being so difficult. But anyway, so I've got Task Manager over here, and we can take a look at memory. If you go under Details, or at least under Processes, you can kind of see what's chewing up all your memory. Chrome tends to be the worst offender just simply because browsers have become the new operating system, where most of what you do nowadays tends to be in a browser, whether that be surfing your favorite web page, or like what we're doing now, looking at some notes in a full-on word processor that's loaded up in a browser, right? That's happening more and more and more. So the more memory you have, the better off you're going to be. I think 8 gigs is probably about the minimum that any system should have. You can get by with 4, but the further down below 8 you get, the more you're going to run into issues. Just simply because your machine needs to remember all the stuff that you're doing, and if it's not remembering stuff, then it has to read from the disk, and disk is much slower than memory is. So if you're on a spinning disk and you start up your laptop, you know the feel of having to wait for Chrome or whatever it is you're trying to do to open up, right? You sit there and you wait and you wait and you wait. And you wait. Like if your system is slow enough, your icons aren't even showing up on the desktop like these. They're just that little white page, and then they kind of slowly work their way in, and they become the image. It's all reading from the disk. And if every experience that you had with your computer was reading straight off the disk, you would have a nightmare scenario of never wanting to use a computer ever. And so this kind of explains why people that don't spend any money on their computer, right? They go to Walmart and buy that $1.99 special, and they start to wonder why exactly it is that everything is slow. Yeah, you buy the cheapest everything, and you're not going to have a great experience. So this is where, obviously, SSDs come in, but more than that, this is where lots of RAM comes in. So I think on this machine we've got 12 gigs of RAM, and me just doing what I'm doing is chewing up a little over a third of that. So just by talking to you guys and recording a video, I'm using 4 gigs of RAM. So if I do anything else, we're past that 4 gig threshold. This is why, if you want to do anything other than surf the internet, you're going to need more than 4 gigs of RAM. So anyhow, as we climb up and do more, you'll see exactly what I'm talking about. So anyhow, back to the story. DDR. So SD-RAM back in the 90s was not fast enough. As we increased the amount of power that we could squeeze out of a CPU, this is around Pentium 2, Pentium 3 time. I don't know if anybody remembers those. But as Pentium 4s with hyper-threading came out, you also saw DDR-RAM. The entire point of DDR-RAM is the first D, double. It took the 133 megahertz, well, started at 33, then 66, then the 99, which got sold as 100 megahertz, then 133 megahertz. But 100 megahertz was actually pretty decent for the time. So 133 megahertz was probably top of the line, and then for SD-RAM, and then with the advent of DDR, they clocked everything up to 200, but they sold everything as 400. So the reason for this was that the memory multiplier, so in a CPU, this is more of a PC hardware topic, so I'm not going to cover it too much, but the front side bus is essentially, y'all talked about Northbridge, right? Northbridge, Southbridge, memory controllers, things like that. Okay, so the Northbridge controls or contains the front side bus, and that is the speed and the chip that talks to memory. Front side bus at that time, DDR, at the advent of DDR, which is right about the year 2000, was clocked at about 200 megahertz. The D in DDR, by some clever memory manipulation, was able to quite literally double the speed of your front side bus. So, yeah, shoving twice the amount of data down a 200 megahertz pipe, which worked quite well, actually. And so it turns out that the D in DDR actually happened. So the fastest DDR RAM you could get your hands on was 400 megahertz RAM, but remember that your front side bus is always running at half of that. So this is where memory starts to get really confusing. It was a lot simpler back in those days of SD-RAM, not DDR-RAM, just plain single data rate RAM. Because the number that you got on the box was actually the number that you dealt with all of the time. But now that data is, or the data rate is doubled, you get to deal with a multiple of 2 and then a multiple of 8. So let me explain. So these numbers down here, you'll find DDR 400 as a pretty common speed for DDR memory. Wait for it. Oh yeah, this is super slow. But of course. Oh no! Great, awesome. So anyway, and we've got a lot of this stuff floating around. Wow, it is really slow. There it is. Oh, that's DDR4. Yep, of course it is. And then you end up with all these situations where these numbers repeat. If you haven't noticed, by the way, everything is a power of 2, like everything. So, yeah, these numbers will repeat over and over and over and over again in different ways. Anyhow, so DDR1 at 400 megahertz. Remember that the front side bus is running at 200 megahertz. So, here's where all these numbers come into play. You have your front side bus running at 200 megahertz. You double that because the D in DDR allows you to. The memory itself runs at 400 megahertz. Now that translates into, because we're dealing with RAM, right? And we're talking about gigabytes of RAM. We're talking, and being able to transfer data in as fast as we can possibly do it. That's where this number comes in. So for every type of DDR memory you have, you're going to end up with a PC number. This number is megabytes per second of transfer. And this number comes from, you take that, you multiply it by 8. And then you get this number. So 400 megahertz, multiply that by 8, and you get 3,200 megabytes per second. So this memory is capable, though not always, different scenarios require or end up with different speeds. You'll see this when we start testing our disks as well. But you can get a maximum throughput on memory like this of 3.2 gigabytes per second, right? That's a lot of memory. That's a lot of transfer. So as we move up, though, DDR2 doubled the rates of its predecessor. So you're looking at, this is a good example, DDR2 800. Multiply 800 by 8, and you get 6400. So this will be 6.4 gigabytes per second, or 6400 megabytes per second. Either or. So clock rate times 8, right? Those of you math whizzes. Clock rate times 8 equals transfer rate. And this happened again. DDR3 doubled its predecessor. And you're looking at, I think 1600 was a pretty common speed for DDR3. So how would I get transfer rate off of 1600? 1600 times 8, and whatever that is, it's a big number. 12,000 megabytes per second, or 12.8 gigabytes per second, right? And if you look at, I don't know why I closed that. If you look at modern memory, 2400 is the low end. You'll find a lot of 2400 in your laptops. So if we're looking at 2400, multiply that by 8, 19,000 megabytes per second, or 19 gigs per second. Moving memory from, or moving data from memory to your CPU. That is what that number means. That's how fast RAM can shove stuff down that pipe so your CPU can process it, whatever that may be. And keep in mind, this is slow. In the grand scheme of things, 19 gigabytes per second is slow. Not just for memory, but for data processing. This is slow. There's cache on your CPU as well that we'll talk about just a little bit as we move on. But yeah, cache, I forget what the speeds are, but it's something stupidly fast. This is slow compared to what you've got on your CPU. So 3200 is recommended for AMD processors. So you're getting 25 gigs per second, and 36 is becoming more and more common. Oop. Wow. Wrong. Oh, wow. Okay, one of these days I'll be able to type 3600. You know what? I think I'm just going to go home today. 28.8 gigs per second, right? And that's just really hard to visualize. It's really hard to visualize. But let's say you had 32 gigs of RAM in a system. And let's say that you filled up your memory. In 1 second, you could, slightly more than 1 second, probably like 1.2 seconds or something like that, you could dump the entire contents of memory, 32 gigs, directly into the CPU. Now, that's not saying that the CPU would be able to process all that at the same time, just that visualize that. And think of what Blu-rays are pretty consistently about 32 gigs to 60 gigs or so, depending on what you get. If you're a movie buff like your high quality video, an entire Blu-ray can be, if your processor can handle it, all that data could be processed by the CPU in about a second. And most modern CPUs can probably do that. Though there's DRM and other kind of decoding that you have to do that will make that not possible. Just if it were raw data, your CPU could be able to take care of that. So the one thing that I really want you to get out of this is that RAM is really fast. Really, really fast. Even the slowest DDR4 RAM is insane. But in the grand scheme of things, level 1, 2, and 3 cache that are built into your CPU is still multiples faster than RAM. The other thing is this little formula. When you find RAM to buy or whatever, know what those numbers mean. That number, whatever that is, DDR800, DDR1600, DDR3200, whatever that is double the clock rate of your front side bus on your motherboard. So half of whatever that number is by the DDR is what your front side bus in your Northbridge on your motherboard actually runs at. So you double that number and you get this DDR4 3200 or whatever. That is the clock rate of your memory. Multiply that number by 8 and you get the raw transfer rate from memory to your CPU. That is the maximum theoretical threshold of how fast you can move data from RAM to CPU. So those ideas, every few years, seems like every about 6 to 8 years, we double the threshold of that transfer rate. It's getting fast. It's getting really fast. Now, there's this other idea in memory of ECC, error correcting code. Not a single one of us has any of this in any of our desktops or laptops. This is more a server idea. Now, if you've ever gotten, especially on older machines, blue screens, and if you've ever looked up that code and it said something about memory, this is why. Memory is not perfect. And as there is more and more and more and more memory, it is less perfect. But a lot of times our systems don't actually use all the memory, so we don't run into these issues very often. But every byte of memory that you have on your chips, right? And if you're talking about gigs, 1 gig is 1 billion bytes, right? So you got 32 gigs, you got 32 billion bytes, right? So 32 and 9 zeros. Multiply that number by 8, and you get how many bits? So what is that, like a lot? It is a lot. 240 something billion bits if you had 32 gigs of RAM, right? And each of those bits, as they are used, flip to either a 1 or a 0. Everything in computing always ends up a 1 or a 0. Everything that you do, that video game that you play, the things that you're doing in Chrome, all of it, every bit of it, turns into a 1 or a 0 in RAM. And right, we're talking about over 200 billion of these things if you have 32 gigs of RAM. And each of those bits, every single bit, has to remain correct. Otherwise, when you give that whatever's in memory to the CPU and it's wrong, the CPU will flip out. Most of the time, the CPU can catch this and throw it away. But don't count on that. If you ever run into memory issues, it's probably because of something like this. One of those 1s or 0s got flipped. Not on purpose, obviously. Maybe the software wrote it incorrectly to memory. Maybe the memory is not seated correctly. Maybe you punted your CPU or your whole computer, right? You're shifting your chair and you accidentally kick your computer on the floor or something like that, right? Any of those bits, if they flip, can cause system issues. And if any of those bits flip on, say, like kernel memory or driver, any drivers that are loaded up in memory, anything that is integral to the system, if those bits flip, you're going to end up with a blue screen of some kind, right? Now in Windows 10, you get that frowny face. It's so satisfying. But that's okay on a desktop for the most part, right? Because we were talking about running everything in a browser, and if you're doing all your word processing in a browser, you don't have to worry about saving anymore. It just kind of happens. So I mean, if you're in the middle of writing a document in Google Docs, and one of those bits flip, and you end up with a blue screen and you reboot, it's not that big a deal, right? Desktop usage, if you run into situations like that, aren't that big a deal. But imagine if Google Drive's servers, Google's servers, the server that you were editing that document on had a bit flip and ended up blue screening or kernel panicking and rebooting. Well, now your document's really gone, right? You end up in a situation like that. So you and 100 other people just lost their documents. That's not good. This is where ECC comes in. So ECC tends to find itself on server-side memory. And so we were talking about bits, right? There are 8 bits per byte and however many bytes for the amount of memory that you've got. ECC adds a 9th bit. So for every 8 bit, there is an extra bit. And that bit is working as what's called parity. So if you count up, say you've got how many is that? There, right? Count the ones. How many are there? Is that even or odd? Yeah. So even, or 1. It is even. So in this case, is it even or odd? Odd. So it'll be a 0. So this is it. So let's say we flip that bit. And now this doesn't match anymore. So what ECC does is before it hands off any memory that it contains to the CPU, it does a final parity check. And it says, if this is an even number of bits and this is not 1, throw it away and request it again. From the disk, from the software, from wherever. Wherever it's coming from, request it again. Because this doesn't match, and if we send this to the CPU will either throw it away or panic. And neither of those are good. So, panic is definitely not good, but throwing it away just requires more time. So instead of sending it to the CPU, we'll do that here. And if we need to re-request it, we will. But that way, you avoid kernel panics or blue screens, so your server never has to reboot for fatal errors like that. Now, there are other fatal errors that can cause a server to crash, but this should not be one of them, and ECC is meant to prevent that. Now, ECC is not perfect. What if 2 bits flip? Is that parity right or wrong now? It is correct. ECC would not be able to correct an error or to stop an error from happening if 2 bits in a single byte flips. Because we're only talking about even or odd. There's only 1 bit, 1 or a 0. That's all it can be. So we've decided even or odd. So if 2 bits flip, we're going to send that on to the CPU. And yeah. What's that? It very well might, yes. It very well could cause the same issue of a single bit being flipped, and not checking for it. So the ECC did check for it. It just got confused. You don't typically find more than 1 bit flip. Not typically. Right. So ECC is a pretty darn good fail-safe. Because most of what will happen is, if you get 2 bit flips, it's probably not in the same byte. So that byte will be 3 bytes over in the grand scheme of things, and it'll catch both of those. It'll drop both those bytes and re-request them again. So you are really, really unlucky, or probably have bad RAM if you're getting more than 1 bit flip in a single byte. So ECC is really good at this job. We're talking like in the 90% of getting it right. So we don't really worry about this. And if you run into that situation now, you're probably dealing with bigger problems than ECC or, a single blue screen. There's a good chance that your server's, something's going on with it, and you need to have a human intervene and figure out what the heck's going on. So a lot of times that's a memory test or something like that to find out that, this entire chip on the memory is bad. That's why bits are flipping all over the place. And outside of seeing hardware logs, the only way to know that ECC is doing its job is things are slowing down. That's pretty much it. So you got to feel it. But we have this idea of baselines in server administration where right when you take your server out of the box and get it all set up, nice, neat, whatever, everything is the way that you want it, you take a baseline. It takes 6 seconds for people to do this. It takes half a second for people to do this or that or whatever. And then in 6 months, you check it again. Well, every month is a good idea, right? But you check it often. And if now the thing that took half a second is taking 0.8 seconds, we need to look into that. Why? Why is that happening? Or the thing that used to take 6 seconds is now taking 12 seconds? Why? Why is it now double the amount of time to do this thing that we were doing in 6 seconds before? So that's something that we'll get into a little bit later. But that's the idea, right? The only way to really figure out that ECC is doing its job is that things are slowing down. And the only way to figure out that things are slowing down is to actually have a baseline. Because going off your gut usually doesn't work when you're talking about fractions of a second, right? 0.4 and 0.5 seconds feels the same to us. But when you're doing 0.5 over 100 different times, that really starts to add up. But your end user's not going to complain about it because their gut is testing 0.4 against 0.5. So baselines. Anyhow, like I said, this shows up in servers and high-end workstations only. Like if you spent $2,500 on an HP workstation, you probably have ECC memory. Because your CAD project that is sucking up 40 gigs of memory, you probably don't want to lose that. Yeah. There's no cloud CAD right now. So that's all you. So what you're looking at, memory-intensive applications, you've already dealt with one of these, probably two, virtualization. Right? You get to decide how much memory it's using up, but 2 gigs, 4 gigs, 8 gigs, 16 gigs, whatever you give to a VM, it's sucking that up immediately. So it is memory intensive. You'll see that happen in real time as you turn on a VM. Photoshop, InDesign, Premiere, any of that stuff. Video editing, image editing, any of that stuff, very memory intensive. The more filters you layer on in Photoshop, the more memory you're going to use. Same with video. This is CAD as well, doing any kind of computer-aided drafting, any kind of mapping, blueprinting, any of that stuff. That entire image has to live in RAM while you're manipulating it. Gaming. Yeah, some of you guys know this now. Do y'all see the recommended now? What is the minimum recommended RAM on a game? Anybody? Yeah, it's like 16 now. 16 is the new normal. So if you're trying to build a mid to high end gaming system, you're probably looking to put 32 gigs in that machine. Whew. Yeah. And so just as an aside, when you look on the back of the box and it says 4 gigabytes of memory recommended, it's not talking about your system. It's talking about for that application. So you need 4 gigs of RAM for that application. So if you only have 4 gigs of RAM on your system, you're going to have a bad time, right? So when it says 4 gigs, you should have 8. If it says 8 gigs recommended, you should have more than 8, but 16 is a good, nice multiple. So when games say 16 gigs, yeah, you want to run Chrome in the background? Yeah, good luck. You're going to be swapping a lot. And so next week we're going to talk about virtual memory, and so that swapping idea will make sense. Databases. This is more a server-side thing, but think about Amazon. You go and look up Charmin, because you need a new shipment, 32 rolls, right? I mean, got to have a lot. You stick it in the closet. But every single thing that is looked up in Amazon's warehouse database is stored in RAM somewhere. So every single type of toilet paper that they stock is in memory on a server somewhere. And that's just toilet paper, right? They got everything under the sun, as well as other people's databases, because now they have that third-party seller thing where you can buy from not Amazon. You don't even really notice it unless you actually look. Yeah, got to be careful with that. But it's all in the database, every bit of it. If it was reading off of disks, Amazon would not be where it is today, right? If your lookup took 8.5 seconds, you could probably go to HEB and grab it faster and bring it home, right? Yeah. Proxy servers. This is an idea that you see in larger enterprises. There are tons and tons and tons of proxy servers, but the ones that most people are familiar with are the caching type. And what that means is, imagine you had 500 employees and you knew that about 50 of them hit up AOL.com for their morning news fix every day, right? Because everybody goes to AOL now. But the way that these proxy servers work is it will store in memory the first time someone goes to AOL.com. And right, those news things, they change, but not instantaneously. It's usually every hour or every 2 hours new news stories will crop up, or maybe even every 4 hours, depending on what site you go to. But in memory, it will store the first lookup of that page, so that the next 49 people that hit up that page don't have to download it from the internet. They download it from your local server that got a cache of that web page. And then every subsequent lookup, so say the 51st person that went to that website, but the front page image changed, but everything else stayed the same. So everything that stayed the same, that 51st person will download that from your local server and then go out to the internet and download just that one image. And that'll be cached, and so person number 52 will get a local cached version of the website again. So all of that lives in RAM. So if you're running a proxy server and you have lots of people going to different websites, you gotta have a lot of RAM, because all that stuff is stored in memory. And this used to look like, oh, I can't do it because I'm not logged in. This used to be struck out. This used to have a line through it because it used to be a joke. Now it is not a joke, right? Back in like 2015, 2013, when Chrome was really starting to dominate the internet, dominate the browser wars, Chrome had a few memory leaks, and it just kind of become a running joke to say that, Chrome uses up a whole lot of memory, ha ha ha. It's true now. It's like actually true, like true. And not a joke in any way, shape, or form. Chrome tends to be the highest memory using application on any given system. Unless you're doing one of these things, Chrome is number one. So, yeah, went from joke status to that is for real. And we can prove it. Look at this. It's chewing up almost a gig of memory. And what do I got? A memory website, a shopping website, one Google search, one document, and then Moodle. And we're sucking up a gig of memory. Yeah. So, Mr. 4 gigs of RAM, you're having a tough time keeping up with modern browsers. And this is not a Google Chrome thing. This is just the way that the internet works now. Every website you go to has interactive scripting languages baked right into it. You have to download those images. Those stay in RAM. Every single bit of text that shows up on a website, that's in RAM too. Everything. And then every single, look at this. You see how that's got a little pop out and that changes color when I hover over it? That's a scripting language. That's in RAM too. That drop down box in RAM. That drop down box, RAM. All of it. All of it is in RAM. But it's not loaded up in RAM right when you hover over it. It's loaded up in RAM when you open the page. So whether or not you're using these features, it's in RAM. That's why you end up with, I just opened up 2 tabs, a gig. That's what happens. And God forbid you open up 20 tabs. If you got 4 gigs of RAM, you're really hurting now. So, yeah. That used to be a joke. That is no longer a joke. So we've been kind of monitoring it this entire time, but this is it, right? If you want to monitor RAM in Windows 10, this is where you go. Hit performance, there it is. So I'm sucking up almost 8 gigs of RAM on this machine. Here, at least. I don't even know what I'm looking at, or what I'm doing at that point. But, I mean, it's not really that far-fetched. And that's not to say that using up RAM is bad. Actually, instead of the purple, so like most people when they come and look at this, right, a lot of people will see, 41% used. Oh man, I need to get that down. No. You need to fill that up. Here's the thing about RAM. Unused RAM is wasted RAM. What's the point of having 32 gigs of RAM if you only ever use 5, like on a day-to-day? Why do you have it? You could be just fine with 8. Now, you can make the case, no, I need 32 gigs of RAM because I run 6 VMs at 4 gigs each, all day long, every day. Okay, that's a good case for having a lot of RAM, and then you have yourself 8 gigs for the rest of the system. Not a bad divvying out of RAM. Pretty decent. Your CPU's probably sweating it all day long, but, I mean, your memory's all right. So, unused RAM is wasted RAM. And a lot of times what happens is if you have 16 gigs of RAM or 32 gigs of RAM, Windows will stretch out. The things that you do on a daily basis, Windows will go out and say, this guy actually loads up Microsoft Word every single time he opens up his computer. So I'm just going to go ahead and pre-cache that. I'm going to go ahead and trickle that into RAM. So when he inevitably clicks on Microsoft Word, it'll start up faster than it normally would have had I not done this. Now, SSDs are really taking the pressure off of memory in this case, but to be honest, why not? Unused RAM is wasted RAM. Just chuck it into RAM and dump it out if you don't need it and you need to use the rest of RAM, right? So if you're like at 11 gigs of RAM, in this case over here on the right, if you're at 11 gigs and you're about to open up Chrome because you hadn't had Chrome open in a while, that's fine. Dump out whatever you're not using. So a lot of times, the way that both CPU and memory work in Windows is whatever is used the most is stored in RAM, and if you haven't used it in quite a long time, that is a candidate to be dumped out if, for some reason, memory pressure is high and you need more memory, right? You have Pac-Man running in the background, but you haven't touched it in whatever, or you closed Pac-Man, but it's still in memory, right? Every application that you open up is still in memory when you close it. So you close up Pac-Man, it took up half a gig of RAM, but now you need a gig of RAM. So it's going to dump out Pac-Man and whatever else it can find that hasn't been used in a while to make room for whatever application you just launched. Oh God, he launched Chrome. Let's make some room. So this is kind of defined by these. So in use is actually how much memory is used. Available is the opposite of that, whatever you're not using at the moment. Committed. Now, this is a little different. Committed takes into account paging file. Paging file is essentially anything that the system requires, like the kernel itself, drivers, anything that the system needs, if you look at this paged pool here, that is added to in use, as well as anything virtual. So virtual memory is this idea that while we may not actually need it right now, we don't have enough room in memory to store it all. So I'm going to store it on the disk. That seems kind of counterintuitive just simply because disks are slower than RAM. Well, Windows tends to make room for applications it thinks that you're going to use. So that's where this cached comes in. So I'd mentioned Windows makes good educated guesses on what applications you're going to launch but haven't yet. So it starts caching it up. And you can see here, 8.3 gigs of stuff. So it's actually using up everything. It's got all 16 gigs of memory cached. Well, 7 is used, 8 is cached. And on this system, that's all of it. So while it may not be actually actively using it, whatever I'm about to launch is probably already cached in memory. Makes things pretty fast. So again, this page pool is kernel components, drivers, things like that. Non-paged is what's left. And you can see 59.8 is the actual kernel itself. And then you get some more memory stats, right? So there are 4 slots on this machine, and I've got 2 used. That memory is running at 1600 megahertz. So, looking at this, what is my front side bus running at? Remember, DDR. The front side bus is... What's that? Oh, you divided by 8, didn't you? or something. So take a look, right? 1600 megahertz. So that would be DDR3 1600. What is my front side bus running at? What does the D in DDR stand for? So front side bus is not that. That's transfer speed. So that is the multiplied by 8. Front side bus is the other direction. $800. Yep. Front side bus is always half of your memory speed, and that's because D in DDR stands for double. And so yeah, transfer good thing though. Transfer speed on 1600 megahertz would be whatever 8 times 16 is 64 1 12 800. 12800. So fast, super fast. So in Linux, if you run the free command, typically I always add the -H option. Otherwise, it's going to be showing me bytes. And man, those numbers are way too big. I'm not trying to deal with that. And it doesn't even put commas in it. So like it's hard to see. So if you add the -H option, you get human readable numbers. And that would be 1.9 gigs, 675 megs. So right, megs, gigs, tera, all that. So you're going to see some similar numbers. Total memory. That's self-explanatory, right? Used memory, 1.3 gigs in this case. Free memory that is literally not being used, not being touched at all. Shared memory. We haven't talked about libraries much yet. I think I may have said the word, but that's about it. So know that this is code that is shared between more than one application. So 18 megs is actually being really efficient because more than one app is using it. Buffers and cached. So buffer is basically what's getting ready to be moved to or from RAM. And cached is this same idea as in Windows as cached, right? So Linux is making an educated guess. He usually starts Firefox a couple minutes after he starts up the system, so I went ahead and pre-cached that. 646 megs. That actually looks like that's what's happened. Firefox takes up about half a gig with a couple of tabs. And then swap. Again, that idea that when you've overflowed, you store it on the disk to be put back in RAM whenever it's needed. So we'll get into this a whole lot. There's a whole section next week. We're going to talk about virtual memory, so don't sweat that just yet. And then in Mac, the only real difference between everybody else and Mac is that Mac will actually give you a reading on what's called memory pressure. I had mentioned memory pressure earlier, but the idea of you're running a lot of applications, memory pressure is high. So if you are gobbling up memory, right, starting up a ton of applications right at the very beginning of your of everything else, of starting up your system, memory pressure will be high. So if all of your applications are already loaded up and running and not needing a lot of RAM, memory pressure will then be low. Right? That's the idea. Are you gobbling up memory or not? That's the idea with memory pressure. And then everything else has an analog. Physical memory is the total memory. Memory used is the amount of used memory. Virtual memory is your swap. And so total and used. Then app memory is, they break it out a little further. So application memory is separate from system. So just like Windows had this paged pool and non-paged pool, this is the opposite of that. Well, here we go. Nope. They don't have it. So app memory is the opposite of that paged pool. It's not the kernel. It's not kernel modules or drivers or anything like that. This is, Safari. Everything else. What? Finder, Dock, Activity Monitor, all that. Yeah, and so a lot of that happens to be Chrome takes up a whole lot more memory because it turns out Chrome's got a lot of telemetry built into it, things that it does to kind of track you and give you a better experience, right? I don't know. Not a fan of Google, so I'll be a little tinfoil hatty about it. So take that with a grain of salt. But still, it really does have a lot of telemetry and does a lot of things that that it kind of does on its own, which is why it takes up a little bit more memory, which is why Chrome got the ire of the internet. Why Chrome was the joke and not Internet Explorer or Edge or Firefox or Safari.
I feel like Chrome, well, for school-wise, it's definitely a lot better to have Chrome for years.
It tends to be, yeah. If you're worried about the Google stuff, you can go get Chromium, which is the open source version of Chrome. So Chrome pulls from Chromium and then adds Google bits on top. So Chromium is just Chrome but without the Google bits. But it's still the Chromium engine, which means that all the applications that you're running still work the same. It's the same exact rendering engine. And then if you're familiar with other browsers like Vivaldi or Brave or, I don't know, there's like a gajillion other ones. I think Opera is another Chromium-based one now. Microsoft Edge is now a Chromium-based browser. So all of those browsers, they're all going to work the same. And each individual browser has its own little flavor on top, but it's all the same engine underneath, except Firefox. Firefox and Safari are the only two holdouts. They are not Chromium-based. So anyway, file cache. So file cache is basically memory that is used but is ready to be dumped out at a moment's notice, right? So if, like Pac-Man, right? I was talking about Pac-Man, closing Pac-Man. It's still wired up. Yeah, file cache. That's what that's about. Then wired memory is memory that cannot be compressed, which means it's in active use. And then compressed is, we haven't used it in the past few seconds, so I'm going to compress it up a little bit. If we need it, I can uncompress it on the fly. It doesn't take a whole lot, but it does use up CPU clocks, and which does lower battery life. Battery charge, I guess, because battery life is a whole different thing. But anyway, if you're on a really, really old Mac system, there's a few different words that you might use for some of these things, but on modern Macs, this is pretty up to date. I think there might be a couple of differences last time we checked. The newer Macs don't like you to get in them. I think about 2015 is when they made that change. So newer Macs, you just pretty much get what you get. What you ordered is what you get. All right. So that's it for the theory side of all of this. So on the practical side, I need you guys to go get a little application called HW Info. The link is here. It's not a link. Just highlight it, right click, go to. And if my internet were not... Oh no! Is internet dead? It just thundered right when that happened, right? Is yours good? Oh, hey, no, it really didn't. Okay, let me disconnect and let me connect back up. Let me try this again. Oh no. And y'all are still good? Yeah. Really? What? I guess you guys are on TSSC Wireless, yeah? Yes, WebEx. I know we're having connection problems. And I can't get on TSSC Wireless. Great! Oh, wait. Haha! Wow. That is fantastic. Okay, well, Brownwood, hopefully you can still hear me. All right, so get to HW Info. Click over here on the free download or this download. Be careful of ads. If you guys haven't installed uBlock Origin or something as an ad blocker on your browser, you probably should. Though uBlock Origin will only work for a little while longer on Chrome. They are changing the way that add-ons work. So no more ad blocking for you. Google is primarily an advertising service, so why would they let you block ads, right? That's the idea. Tinfoil hat off now. Anyway, come over and grab the portable version. You don't have to install it. I mean, you can if you want to, but portable's easier. That way you don't have to go and clean up register crap. come down to the free download little drop down and choose local US. That'll start immediately the download. I won't do it again because it's right here. So I open up my little this thingy. I create a folder on my desktop called HW_I. You can name it whatever you want, so I don't care. And then drag all that junk in here, or at least the 64 ones, and then run this HWinfo 64. This thing is probing your hardware, so you need admin rights. Don't mess with these checkboxes right now. We can start to play with those a little bit later on, but for now, just run the thing. It's going to run a few sensors. It's going to take a look at all your hardware, blah, blah, blah. This is a really interesting little box, but we'll come to it in just a minute. Here is what I want you to look at. So, memory. You get a general idea. Maximum supported memory clock. But wait, you say. When we were in memory a minute ago, it said 1600 megahertz. What does this mean? What does this mean? What's that? It is. What is clocked at half speed? Frontside bus. So, in this week's work, I'm asking you what is the memory speed, not the frontside bus or memory clock. Right? The number that would show you on the box, the doubled number. So if you come in here and you see this number, what do you got to do this number before you tell me your answer? Double it. Yep, multiply by 2. Exactly. So for you yahoos that have DDR4 or DDR3 and you're coming over here telling me 800 megahertz, you're wrong. So, pay special attention to it. Most of you have laptops with a frontside bus of 1200 megahertz. So do not tell me 1200. Double it. So those of you with 1600 megahertz in this column, do not tell me 1600, tell me 3200. This is your frontside bus. Double it for your actual memory speed, clock speed. Ooh, that's right. You are on a Mac. There's got to be some way for us to figure that out. You know what? Command-Shift-U.
On the folder?
Yeah, like open up Finder, hit Command-Shift-U. And then inside the Utilities folder, find Terminal. In Linux, you can do an ls-mem. You might be able to do that. So hold that thought. Open up Terminal, and let me go over this real quick, and then we'll come back to that. So, anyhow, I'm asking you for a few things, right? I'm asking you for your current timings. Your timings are here. Now, these are. This gets a little further into how memory works internally. Essentially, these are the speeds from moving memory around. Takes 11 milliseconds to move something from one spot to another. 28 milliseconds to move things from memory to CPU, or to actually react to a request on that. So don't worry too terribly much about that, but these numbers are going to show up. And what you really want to pay attention to is that if you're buying memory, you're buying 1600 megahertz memory, but you have one stick at 11/11/11/28 and another stick at 12/12/12/30, know that lower numbers are faster. Those numbers will get bigger to match those sticks. So while you may be able to take advantage of more memory, you're slowing your memory down overall. So what you want is really just to match what you already have. Or if you're replacing all of it, the lower the better.
If you have one high, one low, it's always going to run at higher?
Yeah, at the higher speed, which is which translates to slower speeds. Yes, so more milliseconds to do the same job. So you got to be careful when you're purchasing on that. But to be honest, most people are just doing Chrome and Word anyway. So if you got mismatched speeds, it's not that big a deal, to be honest. And who's gonna feel 11 milliseconds versus 12 milliseconds? So Overall, it's not a huge issue. There are very few reasons to care too much about these timings overall. But matching them up is always best. Sometimes you get memory that just does not like changing timings, and it will fail. So, fail during post, as in it won't boot. So you got to be careful. And then look, this reminds you, an 8-to-1 ratio. So you take your, it's actually 798.1 megahertz, but it's just shorthanded at 800. Remember, when you're getting transfer speed, double this and then multiply by 8 to get your transfer speed in HW Info. If you found your RAM on Newegg or whatever, it's going to show you 1600 megahertz, so you don't have to double that number. But know that if it says DDR by it, you don't double the number. If you're finding it in HW Info, you do double the number because this is not memory, this is your front side bus. All right, I'm harping on that because people get that wrong all the time because this last quarter of the video they don't watch. All right. And then I want you guys to save yourselves a little report. So save this as summary for clipboard. All right, pay attention here. If you're submitting me a PDF and that PDF is 30 pages long, it's wrong. You are getting like the HTML or the text log file or what. Look at this. Look at this. Like you take the whole thing and you do finish and then it gives you out that report. Let me see. Where's it going to save it? Probably saves it in here. Yeah, it saves out that report. Look how big this is. I'm not going to parse this. Don't send this to me. Nobody should be sending. Yeah, people send this to me. Don't do this. Don't do this. When you save a report and you click summary for clipboard and you click next, it gives you this. Yes. Copy paste this into your document. So much easier, and it gives you all the information that I would be looking for. Right? DDR3, you got your transfer rate in here, right? There's a way to game this lab. Just look and you will find what you need. So you'll find how much memory you got, you find your timings, you find your front side bus, transfer speed, etc., etc. So be aware, all the info that you might need to come across is probably built right into this little thingy, if for some reason you're having trouble figuring it out over here. And that's pretty much it. So use software to dig up information about the memory that you're running on, that you need. And that'll pretty much be it for this. Now in Mac, I'm curious. Let me grab mine real quick. That way I can tinker with it.
I'm not gonna lie, a lot of this stuff is kind of hard to Mac.
Well, this is probably the only time that you'll actually run into issues like this. Later on in the semesters, you probably won't run into any kind of hang-up, because all the software actually works. So while I don't have this up on the screen, I can at least give you some pointers as to what to look for. I'm assuming LSMEM is going to work, but I mean, it is Mac, so there's no telling sometimes. Oh, you know what? I think there might be about this Mac. You might be able to go into there and find it. So let me check the system report first. Yep. Yeah, click on the Apple, click on About This Mac, click on System Report, and that'll take you there. So HW Info is actually basically built right into the Mac. So you don't need to do anything special for it, and there they are. Now, be aware that Mac does not show you the front side bus value. Yeah, the front side bus would be, well, what does it say? So it should say bank 0, bank 1, size, type, and speed. What does that speed say?
On the hardware.
Yeah, under hardware.
Speed is 2.5 gigahertz. That's processor speed.
Okay, click on, so under hardware. Oh, wait, are you in the system information thing?
Yeah, I'm on the system,
Okay, so underneath the hardware drop down, there should be memory. Click on that.
Oh.
And it should tell you size, type, and speed. What does speed say?
The
1600, right.
800 for the front side.
For the front side. But I'm not asking you that. Just so you know, I'm not asking you that. So the value that you have is really what it is. What year model is that?
2015.
Oh, that's right. That's right. That makes sense because I'm on a 2013 and I'm like, how do you have 1600 megahertz, but you have DDR3? That makes sense. Okay.
Which
That.
is, well, isn't this like a late 2010?
Uh.
DDR3?
Yeah, late 2010s. The cutover was about 2016, 2017 when it got when DDR4 started to get really big, and Macs probably started to see him at about the same time. So there's nothing wrong with DDR3 memory at all. Not in our cases. All right. So yeah, HW Info is built right into the Mac. That is nice. All right, well, that'll make it extra easy for you. You get to skip a lot of this, but what I would like for your system summary, though, just so you have all the things, I think you can save a report. Yeah. Let me see. I think you're not going to be able to get away with it. I think your system report is just going to be stupid massive. Let me see what oh, show less info. That might help. You know what? The About This Mac page is good enough. So instead of doing a save report of any kind, just take a screenshot of the About This Mac little window.
That's what I'm running.
Yeah, version of the OS and some basic info. Yeah, that's going to be good enough. Man, you get an Easy Lab. All right, cool. So that'll do for you and anybody else that may or may not have a Mac over in Brownwood. So the system report will get you the info, and then just give me an About This Mac screenshot. That will be good enough for this summary for clipboard, the About This Mac there. Now, everything else should work just fine, though.
Trying to find like a new RAM since Macs you can't upgrade the RAM.
In yours, you can. Yours is the last model that you're able to actually do that in. Yeah. So if you have 8, it shouldn't be. It shouldn't be soldered in the 2015s. In the 2016s and laters, it's soldered on. Unless you know this, as in you looked it up or something.
Well, I was on like Mag or something like that.
Uh-huh.
And I was reading about it, and it did say like the 2015 was soldered,
Really?
but it might not be right.
No. I mean, I would trust that resource more than me because mine's just sheer memory. Huh. Okay. So it may be like early or mid 2015s. That was it. But you've got 16 gigs, yeah? Okay, so you're okay. You won't need them, but just assume that it's not soldered in, and just look for 32 gigs of the stuff that you got. And then same for everybody else. Just if you can't find faster RAM for your laptop, then just go for more. And ignore one of the things that you can do, one of the easiest ways to do this is these guys have a website. If it will go, this website will actually do a lot of that selection for you.
Oh, yeah. See, we've done that, or I did.
Yeah.
It always tells me I can't upgrade.
Really? So okay. So I guess the late models you can't do that with. Let's see.
On the summary
Let's try the early, because you have a late model, right? What's that?
on the summary report, what are you looking for?
Just all that text. Just, yeah, paste that text into the PDF and then submit that to me.
That right there.
Not that. It is summary for clipboard. Here, hang on. I don't have it open. Let me, 1 sec. Currently does not have, oh, really? So none of the 2015s.
So I want to say like they're all soldered.
Wow. They sure are. Well, at least you got the good keyboard. And 16 gigs of RAM in the first place, so. Here, let me open up HW Info. Show you what I'm talking about. This, under Save Report. Summary for clipboard. That's what I want in the PDF.
Okay.
Just copy paste it. So what about a 2014? Maybe not. Did they just not make any in 2014? What? Oh wow, I think they might not have. Oh no, they're there. Okay. MacBook Pro, Retina 13, 2014. Let's go. I have a feeling.
It's not gonna show the timing.
It may not. All right. Well, either way, that's it. I'll stop the recording here. That way, you don't have to pretend like you're watching anything.